What's up, guys? Welcome to the QBUS5002 midterm exam online consultation session. This is Tony speaking here. So in this session, I'm basically answering some of your questions if I can. And yeah, that's all. So please feel free to ask questions in the chat area. But before you're doing that, please log on YouTube using your Gmail account. All right? Okay, so can everybody hear me? If you can, please say yes. Right, nobody says anything. Hi all, yeah, hi, yes, okay, great. You can listen to it, great, beautiful. Okay. No. Someone says no. No. Okay. Please adjust your ear tube. Okay. Right. Now let's look at the questions from. Oh, it seems like stuck. Let's look at the questions from our students. Okay. I think it just stuck. So let's. I'll say what I'm saying again. So let's look at the first question from Baby King. Can you see the question from Baby King? He or she says, "Hi Tony, I wonder, do we need to do the sampling distribution of sample mean using the standardization manually or directly use the Excel command?" My answer is both will be fine. Because once you can reach the same answer, it doesn't make any difference, right? But if the question asks you to show the process of standardization, you need to do the standardization. But look, you can get the same result, right? As long as you can get the results the same, then you don't need to do any standardization. That's my suggestion. So for example, if we want to calculate if x follows a normal distribution with mean mu and variance sigma square and over n, something like that, right? And you want to know x bar. So you want to know the probability of x bar less than, for example, a small x bar value. Is that right? So it can be calculated directly using the norm dot dist. Is that right? And we have small x bar over here, and you put the mean mu and variance, put the standard deviation sigma divided by square root of n, and 1 over here. So this is one possible way of calculating this probability. Another way is that you can standardize this normal random variable to make it a z. So z will equal x bar minus mu divided by sigma squared divided by square root of n, and it becomes z less than small x bar minus mu divided by sigma divided by square root of n. And yeah, so this probability, you need to use the norm dot s dot dist. And then we have x bar minus mu divided by sigma divided by square root of n, and then 1. So they will give you the exact same result. So both way is fine, okay? Both of them is fine for your exams. So it's all about how the question is requiring, okay? Right. So Baby King, I hope I answered your question. Now, let's look at the next question from Reina Lee. She's asking, "Hi Tony, do we need to keep 2 or 4 decimal places in the exam? Please follow the instructions of the question." So the question will explicitly tell you how many decimal places you need to keep for the results. And another thing is, if you calculate something in the middle, which is not a final result, my suggestion is that you should keep as many decimal places as possible. But since this exam is marked by human beings, so if your result is very close, then we won't mark you wrong, okay? So don't worry about that. And the result the question will ask you how many decimal places you need to keep. If they didn't say how many decimal places, I suggest 4. Okay, I suggest 4 because 4 is precise enough. Right. Now, any other questions? Any other questions? So Georgina Lloyd is asking, hi Tony, tips would you give for students that feel they have no idea what is going on? Can you list some basics to keep in mind when going to the exam on Sunday? Wow, that is a good question. Any tips would you give for students that feel they have no idea what is going on? Can you list some basics to keep in mind when going into the exam on Sunday? Well, any particular things you want to know? I mean, you need to, well, have you tried the sample exam from 2015? If, I guess the question will be pretty much the similar as that one. So, any tips? Georgina, can you please specify what kind of tips do you want? Okay, and I will move on to others' question first. All right. Now, Zhao Andy is asking, hi, how to understand Excel function like Poisson? Right. How to understand Excel functions like Poisson? How to understand? Well, it's all about calculating some probabilities of a random variable. So for example, if any random variable x follows a Poisson distribution with the mean mu, and this means x can be, for example, a very rare event and happen in a given interval, right, from the definition. So if we want to know, for example, in a real life, let's take a real life example. For example, how many phones will you receive? Phones you receive in 1 hour, okay? And let's suppose mu equal to 3. And now I want to ask about x, the number of phones you receive in 1 hour is a random variable, and we define it as x. So x will follow a Poisson distribution with a mean equal to 3, which is just 3, like average 3 calls you receive in 1 hour. So the question will probably ask, what is the probability of receiving less than or equal to 2 phone calls within 1 hour? Or what is the probability of exactly getting 2 phone calls within 1 hour? All right. So in this case, if it's less than 2, you're going to use the Poisson distribution, Poisson.dist. And you're going to input 2, and what is mu? Mu is 3, and cumulative or not, so true or 1, okay? Because less than or equal to is true. So this Poisson is basically, for example, this is Poisson distribution, okay? Something like that. And it is basically ask you what is the probability of x less than, this is 2, for example, this is 0, 1, 2, less than or equal to 2. So it's just asking the probability of less than or equal to 2. So the probability under this area, so it's calculated in this way. And again, if it's x equal to 2, then you need to use the Poisson.dist 2, 3, 0. 0 is for non-cumulative, which means you will get exactly the probability of x equal to 2, okay? So the probability of x equal to 2. So this is how you understand the Excel functions of any kinds of distribution, all right? So hopefully it answers your question, okay? Andy Zhao. Redan Fang is asking, hi Tony, in normal distribution, if we got PZ less than 1.5, how can we calculate the Z less than 1.5? What do you mean by that? What do you mean? I mean, Do you mean that if we know the probability of x less than something is equal to some probability? So do you asking that? And how do we find this small x? Do you mean that? I suppose you are asking this, okay? Read and Fang, all right? So I guess you're asking this. When we know the probability, and how do we calculate what is small x, right? So before we know, for example, if it's z less than small z, whatever. So if this is a normal standard normal distribution, and we can calculate two things. So first of all, if we know this is 1.5, and we can calculate the probability to the left-hand side of 1.5, right? So in this way, z less than 1.5's probability can be calculated using the norm.s.dist, right? .dist with 1.5 and cumulative, right? 1.5 and 1 for cumulative. Now, what if I already know the probability of z less than some z equals this area, for example, a probability p? How can I find this z, okay? So for example, if this probability is, say, 0.6, okay, to the left-hand side, how can I find this critical value? So this can be done by norm.s.inverse. So it's basically the inverse of that process, right? So we know 1.5, and we can calculate the left-hand side probability using norm.s.dist. And if we know the probability, but we want to know this value, z, then we use norm.s.inverse. So it's the inverse of the last process. Therefore, we can just input the probability 0.6 over here, and you can get the value of z, okay? So you can get the z value over here. So I guess you are asking this, okay? So hopefully read and Fang, I was answering your question, okay? If you're still unsatisfied, please follow up your question, okay? Now, let's look at Joyce Huang. Hi, Tony. About the formula chart, if some formulas are not in the chart, does it mean they will not be used during the exam? Well, JC, I have no idea of what's going on in the exam, so you better ask Boris, other than me, okay? But yeah, I guess so, but I don't know. Because, well, for the formula sheet, my suggestion is that the best way of using formula sheet is not to use it, okay? You'd better memorize everything. But you can just use it if you cannot remember the detail of some formula. So for example, if we have x bar plus or minus z half an alpha times sigma divided by square root of n, and you just unsure if here is sigma or sigma square, and then you check the formula sheet, okay? It doesn't mean that when you want to do something and, okay, you have no idea of what the formula look like, and then you search it one by one. And I'm pretty sure if you rely too much on the formula sheet, you will never finish the exam question in time, okay? So formula sheet is just in case you forget, right? Because before you remember the formula sheet, you can never really being able to understand it, all right? So JC Huang, I hope I answered your question, okay? Now let's look at Georgia Lloyd. Hi, Tony. I guess if you can condense the first 5 weeks into the main things we have to try and achieve. Oh my God, that's a whole lot of works to do, right? But I think it's good to have a whole picture of what you've learned from the first 5 weeks. Is that right? Okay, so again, first of all, I didn't really know what's going on in the exam, okay? So I can just list some things that I think is important and give you a whole picture of what's going on, what was going on in the first 5 weeks, okay? So, this course is basically about statistics, right? And we need to pay attention on the word statistics. It is actually a plural of statistic, right? So our main task of statistics is actually to use statistic to infer the value of parameter, parameters, right? So this is the main task of statistics. So parameters can be population mean, or population proportion, or population variance, or standard deviation. Those are called population parameters. They are the descriptive measures of a population, right? So those are the values that we are interested in. Is that right? However, in reality, we can never reach the whole population. Therefore, we can never know the exact value of the parameter. Therefore, we're going to use statistics from a sample to infer the value of the parameters. So in terms of, if we want to infer the value of mu, we use x bar, which is sample mean, right? If we want to estimate p, we use p hat. And if we want to estimate sigma, we use S, which is the sample standard deviation, sample proportion, and sample mean. And one thing you need to keep in mind is that statistics are random variables, right? They are random. Because every time you take a different sample, you will observe an absolutely different result. For example, sample mean, right? If I have a population 1, 2, 3, and want to take sample of size 2. So first time if I take 1, 2, the sample mean is 1.5. 2 and 3, 2.5. 1 and 3, 2. So every time you take a different sample, you will get a different value of the sample statistic. Therefore, sample statistics are all random. So if they are random variables, it's very important to know the feature of the random variables. But before that, in the first week, we are basically learning the descriptive measures, right? Descriptive measures. So what are the measurements of central location and variation and association, that sort of things, right? Because before we really want to infer the parameter, we need to know how do we describe. For example, if we want to know the central location of the parameter, we use population mean, right? Central location of a population, then we use population mean. Is that right? So in week 1, we learn some descriptive measures. So all you need to know are the descriptive measures of central tendency, which are mean, mode, and median, and variation. We have variance, variance, standard deviation, and coefficient of variation, that sort of stuff. And we have association measurement, we have covariance correlation coefficients, and we also have relative standing, median, percentiles, quartiles, whatsoever. So in week 1, all you need to know are the different measurements of a data, right? And in week 2, we start dealing with probabilities, right? Because probabilities are very important because later on we're going to use probability to stand for like type 1 errors probability, which is significant level, or confidence level, which are all the probability concepts. So in probability, I guess one more thing you need to pay attention on is to use probability tree and Bayes theorem, okay? So those are probably something that you need to pay special attention on. And for the rest of probability, they are not very hard. And also you need to know some concepts of events, like what are the independent events, how do we know the events are independent or not, or we need to know the joint probabilities, marginal probabilities, and conditional probabilities, okay? marginal and conditional, right? Those are the things about probability, right? Right, so in week 3, and basically week 3 and 4, we learn different types of random variables, right? And different types of distributions. So in terms of random variables, we learn discrete random variables and continuous random variables. Discrete and continuous. And we know the reason of learning random variable is that our statistics are random variables. So we need to know the features of them. So the only feature that we are interested in for all random variables is their probability distribution, right? This is a very important concept. Probability distribution, right? Okay, probability distribution. So you need to know the discrete ones like binomial distribution, Poisson distribution. And for continuous one, you need to know exponential distribution, uniform distribution, as well as normal distribution, right? So you need to know all the distributions and how to calculate the expected value of a random variable and the variance of a random variable. Also, the sum of expected value of sum of the two random variables and the variance of the sum of the two random variables. Those formulas are all on your formula sheets, okay? So those are the basic concepts of statistics. So far, we know random variable, we know probabilities. Now it's the time for us to really know what are the distribution of those statistics, okay? So what are the distribution of those statistics? So that's why we learn week 5. So in week 5, we learn the sampling distribution of the statistics. Because we want to estimate the parameter. So we need to know the feature and how those random statistics are distributed in order to really estimate the parameters precisely, like building up the confidence interval or doing any hypothesis testing. We all need the sampling distribution of those statistics. So in this unit, we only learn 2 things about the statistics distribution. One is the sample means distribution, right? This is called central limit theorem. So sample means distribution has 2 optional conditions. So first, if the population is normal or the sample size is greater than 30, then X bar can be approximated by a normal distribution. But here you need to pay attention. X bar is a sample mean, okay? We are talking about the distribution of sample mean, all right? The distribution of sample mean. It's not sample distribution. It's the sampling distribution of sample mean. So the sample mean is a random variable. As I said, if we have a population, we can get different results of the sample mean, right? So we just want to know how these values are distributed among different values and what are the probabilities, right? So here we know X bar can be approximated by a normal distribution, and the mean is always mu, the population mean mu, and the variance is always sigma squared divided by n, which means that the variance of X bar is affected by the sample size. And it actually makes sense. When we increase the sample size, the X bar will more likely to be close to the true value of the population mean, right? And the extreme condition is that if n is infinity, or it's just equal to the population size, and then sample mean is just population mean, right? It has no variance at all. It's just the population variance, all right? So this is what we know about the sampling distribution of X bar so far in week 5. And in week 6, we apply this result to construct a confidence interval, right? But our exam will only cover up to week 5. And another statistic is p hat. So we also want to know the sample proportions distribution also the sample proportion is again a random variable. For example, if I want to know the proportion of males of the University of Sydney, so I can take a sample and calculate the proportion of males. But every time I take a different sample, then the proportion of males will varies, right? Okay, so that's why p hat is also a random variable. So in terms of p hat, again, if np greater than 5, n times 1 minus t also greater than 5, we can have p hat also approximated by a normal distribution with a mean that equal to population mean p and the variance of p times 1 minus p divided by n. So those are the key things you need to know in week 5, all right? So in week 5, up to week 5, the question will probably ask you to calculate some probabilities, like what is the probability of sample mean greater than 30, for example, or sample mean less than 20. And then you can just, using this result, knowing that it follows a normal distribution. So the probability of x bar less than 30 is simply equal to norm dot dist, right? And with 30, and the mean is sample population mean mu, and the standard deviation sigma divided by square root of n, and 1, something like that, right? So it's very, very easy, all right? Nothing too much about week 1 to 5. So we can see week 1 to 5 contents are just one step further than the previous topics. So in week 1, we know some basic descriptive measures like mean, variance, covariance, many things. And week 2, we have some basic knowledge about probability, which is useful in our random variables learnings, right? And in week 3 and 4, we are focusing on different types of random variables, and we know the features of random variables, and we know different types of distributions as well, and we also know some random variable rules. And in week 5, we apply all the knowledge we learned from 1 to 4 and aiming to know the distribution of statistics as random variables, right? So we know the distribution of x bar, and we also know the distribution of p hat. So this is basically the whole picture of what's going on before your mid-semester exam. And after your mid-semester exam, we start doing estimations on parameters, right? We build up confidence intervals for population mean. We also have hypothesis testing, like mu equal 10 or mu less than 10. We will do this kind of tests. And they are really the estimation process of statistics, okay? So, that's a long whole picture. Hopefully it helps, okay? Let's see if the number of watchings has dropped. Okay, it hasn't dropped, so it makes sense, right? All right. Let's see where we are now. Okay, so Georgia Lloyd, this is my answer to your question, and this is a whole picture, a big picture of what's going on in week 1 to 5. So hopefully it helps with your revision, okay? Now, let's look at the next question from whom? Dan Wu. Okay, Dan Wu is asking, hi, Tony. A question P, okay, similar question, right? Again, if we know the probability of x minus something, like small x, equals 0.95, so how can we find x? Again, we know that we need to use norm. Well, first of all, we need to know the distribution of x, okay? So for example, if x follows a normal distribution with mean mu and variance sigma square, and then we can use norm dot inverse. So every time, no matter what kind of distribution it is, just use the inverse function, okay? Norm dot inverse with for example, the probability over here is 0.95, and the mean, you need to input mean mu and the standard deviation sigma, and that's all, okay? So you use the inverse function to find out the x, okay? Right, Dan Wu, I hope I answered your question. Mia Sun, hi Tony. In 2015 mid-semester exam, a question is about achieving portfolio diversification. What does this mean? Okay, for portfolio diversification, we know that if we have two stocks, one has expected return of, for example, 10%. This is one, and ER2 is 5%, and the variance of R1 is for example 0.01, and the variance of R2 is, for example, 0.025. Is that okay? No, not 25. 0.005, something like that, because this one must be less than this one. Now, what is portfolio diversification? We know that if we want to have a portfolio with weight 1 on stock 1 and weight 2 on stock 2, we know its portfolio return is going to be weight 1 ER1 plus weight 2 ER2. So this is the portfolio expected return, and the portfolio variance is given by weight 1 square sigma 1 square. I just use sigma 1 square to stand for this. Okay, so this is sigma 1 square, this is sigma 2 square, plus weight 2 square sigma 2 square plus 2 times weight 1 weight 2 sigma 1 2, or covariance 1 2, right? So portfolio diversification means the portfolio return less than any of the return of each stock. Okay, so this is 0.01, it less than 0.01, or even less than 0.05. So if we achieve the result of the variance of portfolio is less than each of the stocks, we say we achieve portfolio diversification. And for more details of portfolio diversification, I do have a video actually in this YouTube channel, which is called episode 1, I guess. And it will in detail explain what is portfolio diversification. Okay, so I can post you the link to that video, or you can explore it later in our channel. Okay, so let's see, where is that video? Videos, portfolio diversification. Okay, I found it. So the video is here. I just post the link to that video. Okay, so if you click on that video, you will know the portfolio diversification, okay, in more details, and also you can find it out in our channel. Okay, now let's look at Xiaofei Okay, hi Tony, can you explain question 3A2 of mid-semester examination 2015 semester 1? I haven't got that question, but I can find it out. Okay, I will find it out what you mean by that. QBUS5002, and we have where is the question? Okay, 2000 mid-semester exam template, Excel file for mid-semester exam. It's okay, I got it. Question 3A1. Let me have a look at. Question 3A2. Question 3A2. All right, normal approximation to binomial probabilities. Again, I don't think you learned this in QBUS5002, but if you do want to know normal approximation of binomial probabilities, we do have another video showing that, but I don't think it is learned in QBUS5002, okay? But I will copy this link and show it to you over here. Okay, so this is the link to this is the link to normal approximation. normal approximation of binomial probabilities. So just for your interest, I don't know if you learned this, but I didn't see it in the Excel. In the tutorial questions. Okay, so 消费 law. Please see the links I just put up. Okay, the second link, and this will definitely answer your question in much more details. Zhao Andy got it. Thanks. No worries. Taiko Ken is asking, hi, why this statement? A histogram generally has no gaps between rectangles because it's a graphical display, a numerical variable, and the horizontal axis follows a number of scale is true. Oh, it stops. What's going on? What's going on? Okay, well, let's look at the question from Tanko Ken. It's as a histogram generally has no gaps between rectangles. That is right. So for a histogram, we are actually showing the frequency of the numbers lying into each interval. So for example, this is 0 to 10, this is 11 to 20, 20 to 30, something like that. They are intervals. So they will be close to each other for each rectangles, okay? So this means there is no gaps between each rectangles. Because it is a graphical display of a numerical variable, so in the x-axis, they are the range of the numerical variable. That is true. And the horizontal axis follow a number of scale. Well, yeah, the horizontal axis follows a number scale. So the frequency is the number scale. So 1, 2, 3, 4, 5 is the number scale, right? And that is true. So it's just describe like the feature of a histogram. So this means you need to really understand what is the histogram before you look at this true and false question, okay? Right, let's look at the question from Michael Wang. She asked, hi Tony, can you please show us an example about the process to answer a question and get full points, such as at the beginning elect X, B, and then. All right, let's take a quick example of your 2015 exam question. Is that okay? So let's look at look at what? What do you think? Let's look at question 3A1, okay? Let's look at question 3A1. So like a binomial distribution question, right? So if you don't have the question with you, please quickly have the question with you, okay? Because I haven't printed out. Do you want me to print it out? Or let's just look at it here. Whatever you like. Do you want me to print it out? Nobody says. Okay, no worries. Now let's just look at the question. Just the Citibank Australia question, okay? So it says, Citibank Australia is one of the credit card issuers in Australia, and it uses a credit scorecard to determine whether or not a credit card application will be approved. According to internal document of the credit card department, 40% of applications have been rejected. On a particular business day during a promotion period, 400 applications are received. And question 1 is asking to find the probability that more than 250 applications are successfully using Excel. So 400 are received. This is definitely the number of successful applications just follows a binomial distribution, because this is a Bernoulli trial, right? Only 2 results, success or not success, and repeated for 400 times. So this is definitely a typical binomial distribution question. So what we can do to this question to achieve full mark is that, what's going on? What we can do to achieve full mark is that we need to first define the random variable, right? because in the question, it doesn't define any random variable for us. So we need to think about what is the random variable in this question. So in this question, the random variable is actually what? The number of successful applications, right? The number of successful applications. And therefore, we can let x be the number of successful applications within the 400 applications, right? So we define x to be this, and then we need to specify the x probability distribution, because this is a random variable. And keep in mind, for random variable, you should always use big X instead of small x, okay? Big letter is random variable. Small letter is the observed value of a random variable, okay? So let X be the number of successful applications within 400 applicants, and therefore, X follows, you need to specify the distribution that X follows, right? X follows binomial distribution NP. So N is 400 and P is 40. So 40 is rejected. Now, 40 is rejected, so 60% of them is not rejected. So it's 400, 0.6, okay? So now, we need to find the probability, find the probability of X, what? More than 250, more than 250. So if it is more than 250, it's going to be 1 minus the probability of X less than or equal to 250. Is that right? So once you get that, you can just go to Excel and type in equal 1 minus binom dot dist. Is that right? And we have 250 with n 400 and p 0.6 with cumulative results, right? And you do this in Excel and you can find the results, right? So the results will be something, right? So this is the whole process of answering this kind of question, okay? I don't know the number because I can't really calculate this, right? Okay, this is basically the full process of answering a random variable type of question. So you need to define what is random or what is the random variable in the question, right? So in this case, the number of successful application is the random variable because within 400, it can be any number, right? With different probabilities. So therefore, we know X follows a binomial distribution. And once we know the distribution, we can calculate the probability, okay? So hopefully this answers your question. Who is that? Michael Huang, okay? So Michael Huang, hopefully this answers your question. Now, let's look at the question from Lu Zheng. Can you simply explain what are variance, standard deviation, and coefficient of variation? And can you explain the difference between Poisson distribution and exponential distribution? Right. Okay. Those are pretty nice questions. So variance. What is variance? So first of all of variance, standard deviation, coefficient of variation are the measurements of the volatility or variation of a type of data. So for example, if we have a data set like this, and we know it's not a single value data, right? It varies. And some other data are like this. So obviously, this set of data is more volatile than this set of data. Is that right? So probably x-axis can be the number of observations or the observation number. And the y-axis is just the value, okay? So we can see this set of data is much less volatile than this data. So how can we measure this kind of variation? Is that right? So that's why we include variance. We introduce variance. Because we can see if a set of data really varies, then we can see each observation on average has a very long distance to its average number, right? Or the mean. And if a set of data is not that volatile or just not that variates, then we can see the distance of the observation from the mean is not that far. Is that right? So we just want to, if we take the average of all the distance, then it can be a measure of the variation of the set of data. So this is how we do variance. So what is each observation over its mean? So if we have any observation xi and minus x bar, this is each observation, the distance between each observation and its mean. But problem is some of this difference are positive, others are negative, and they can be cancelled out. Is that right? So if they cancelled out, we cannot do much. So it will not reflect the true variation of the set of data. So we want always to make the distance positive by taking a square. Is that okay? So for each of observation, we can have a distance square. So we add them all together from the first observation to the nth observation and divide it by the degree of freedom, n-1. Well, why n-1? You don't need to know that, but it's just like taking an average. So this is just describing the average distance square of a set of data. So that if this average distance square is large, this means this set of data is volatile. And if it is small, this means this data is not that volatile, okay? So this is how we understand variance. However, if we have a look at on the unit of the variance, so for example, if the unit of x is $, so what is the unit of a variance? It must be something $square, and this $square doesn't make any sense at all. Therefore, what we choose to do is to get a square root of the variance of x, for example. And this is defined as standard deviation of x. And this standard deviation has, if we take a square of it, the unit of it becomes just the $. And we can interpret this result in real life, right? So this is why we have standard deviation to measure the variation as well. However, another problem is that even though standard deviation really measures the value of measures the variation, but if we see we have two sets of data, okay, and we want to compare their variations, okay, so we have data set 1, data set 2. And if we observe data set 1 has a very standard deviation of $1,000, and 2 has 2,000 Japanese yuan, can we really compare those variations? Not really, because the units are different. Also, the magnitude of those data are also different. Look, even though they are just in Australian dollars, okay, the magnitude can be different. For example, in our data set 1, all the values are like 10,000 something, and it has a variation of 1,000. So for example, if the average is 1,000, okay? But what if for data set 2, we have an average of 100,000? So which set of data do you think is more volatile? It must be the first one, right? Because the magnitude of this data is relatively small. So the variation of 1,000 can be a very large number compared with 1,000 variation in 100,000. Is that right? So this is why we use CV, coefficient of variation, because if we calculate CV1, we can get a percentage of the standard variation, right? So the first one, CV1, becomes 1,000 divided by 10,000 is 0.1. But CV2 is actually 1 divided by 100, which is 0.01. So in this way, we can eliminate the effect of the magnitude and the unit of the data and purely get a number that is mostly less than 1 or percentage value, and we can compare the variation of those two data sets, okay? So CV makes two different things comparable, okay? So those are the three measurements of variations. We first have variance to be the average square of the distance from the data's mean. And we take a square root of it to eliminate the square unit because it's hard to explain. And we have CV in order to make different variations of data comparable with each other by eliminating the magnitude of the data as well as eliminating the units of the data, okay? So those are the variances, standard deviation, and coefficient of variations, okay? So hopefully I answered your question, Lu Zheng. And another question by Lu Zheng is that, can you explain the difference between Poisson distribution and exponential distribution? Please read the slides, okay? I mean, that's a good question. And Poisson distribution is a discrete, okay? It's a discrete distribution. And exponential is continuous, so they are different. But discrete distribution, and it usually measures the number of something to happen within an interval, okay? So for example, in 1 hour, how many phone calls can you receive? But exponential distribution is a random variable that measures the waiting time, for example, the waiting time of the next rare things to happen, okay? So those are the differences between Poisson distribution and exponential distribution. Now let's look at the question from Reina Lee. A discrete or continuous random variable from any probability distribution can be approximated by normal distribution based on central limit theorem if at least 30 this is definitely wrong, okay? Reina Lee, this is definitely wrong because, again, as I explained, central limit theorem tells you the sampling distribution of sample mean, okay? Its sample mean follows what kind of distribution. It's not saying any distribution can be approximated by normal, okay? We can never say that, okay? It's the sampling distribution of sample mean follows, can be approximated by a normal distribution, okay? So this is why it is wrong. It says a discrete or continuous random variable can be approximated by normal distribution. That's very wrong, okay? Because we need to focus on the subject of central limit theorem. It says the sampling distribution of sample mean can be approximated by a normal distribution, okay? Now, let's look at the question from Baby King. Do we need to write down Excel commands during exam? If the question asks you to write down the commands, then you write down the commands. If it doesn't ask you, then you probably don't. Now, let's look at the question from Leslie Shen. Hi, Tony. I'm still confused about when should we use big X and small x. Will I lose some marks if I use it in a wrong way? Yes, definitely. Big X is for random variable, and small x is for the observation of random variables, okay? So if you define some random variable, you always use large letters like X or X bar or whatsoever. Big letters are random variables. But if you observe a sample mean that equals to 10, and we know that this 10 is denoted by small x bar, okay? So it can be 10 or small x bar. Small x bar is a general form of the observed value of a particular random variable, okay? So more particularly, x can be equal to any small value, x1, x2, x3, or xn. Is that okay? For example, if this is a random variable, and it can take n values like this. So each of the observed value is small x. So if we know what the value are, we do not use small x. We can directly use, for example, 3, 4, 6 to 110. Something like that, or 101, okay? So those things are small x, and this is big X. This is a random variable, and it can take any value with some probabilities. Okay, so this is the difference between big X and small x. Now, let's look at a question from Dan Wu. Hi, Tony. Do we need to write a conclusion to answer a question? Yes, probably you should. I mean, if you have time, write it down, okay? All right. Now, let's look at the question from Crystal Han. Hi, Tony. I'm not sure when I should use binomial distribution, when to use Poisson distribution. Thank you. Well, yes, I think, yeah, that's a very good question. It shows your deep critical thinking of those distributions. Again, just focus on the questions, okay? Because binomial distribution, the key thing is to find out a Bernoulli trial or Bernoulli experiment, an experiment that only have two results, right? And another thing you need to know is the probability of success or fail, right? And again, we will repeat this Bernoulli trial for n times. And thus, if x defined as the number of success, then x will follow a binomial distribution NP, okay? So you can see, it's very obvious. First thing, Bernoulli trial. For example, if it's like a male or female, and have you tried doing this for n times? So this is when you use binomial distribution. But for Poisson distribution, is to see how many times something happened in an interval, okay? In a given interval. It usually be a time interval. For example, the hotline phone, right? So if you know, on average, within 1 hour, you will receive 3 hotlines in 1 hour. And then if X is the number of phone calls received in 1 hour, then X will follow a Poisson distribution with mu equal to 3. So we can see within 1 hour, it's not like different trials. We try how many times and see how many phone calls we receive. It's not like that. Not like receive a phone call or not receive a phone call, okay? But it's pretty much like within a given time period, how many of phone calls will we receive, okay? So X now follows a Poisson distribution. All right, so those are the different stories of binomial and Poisson distribution. Raymond Liao, hi Tony, can you explain the definition of standard error? That's a pretty good question. I think you must not from my tutorial. So if you are from my tutorial, you will know the standard error very well. But look, I know, but standard error is nothing hard. Now, we have estimators, is that right? For example, X bar is an estimator of mu, is that right? Okay, so we know that X bar is a random variable or a fixed value. What do you think? It must be a random variable, right? Because sample mean, random variable. So when the sample mean is acting as an estimator, there are some new definitions on X bar's feature as a random variable. So as a random variable, we have, for example, probability distribution. Right? But if this random variable is acting as an estimator, but it's still random variable, okay? But if it take a special position of estimator, we call it sampling distribution. Sampling distribution, estimators. So it's just the probability distribution of an estimator, all right? But when this random variable take into the position of estimator of this mu, we call it sampling distribution. Is that okay? So this is just another name of probability distribution. So for any distribution, they have their own means and variance and standard deviation. Is that right? For different random variables. So for estimators, the mean is also called a mean, and the variance is still called the variance. but the standard deviation is called standard error. So that's the only difference. So the standard error is just the standard deviation of an estimator. So for example, if x bar follows a normal distribution with mean mu and variance sigma squared divided by n, the standard error of x bar just equal to the square root of the variance, sigma divided by square root of n, okay? So this is the standard error. It's just standard deviation of x bar, okay? So standard error is just the standard deviation of an estimator, okay? Nothing much, just standard, another name of standard deviation, okay? Right, hopefully I answered your question, okay? Ramen Liao. And Ramen Liao is asking if I want to know if we need to use the comments like var_p.var_s, I mean the comments for population sample instead of equal var. Yes, you do, because mostly we are dealing with sample data, right? So but sometimes if it is specified, it can also be a population data. But most likely we are dealing with sample data. So you need to know the difference between var.p and var.s, okay? Rena Lee, quantitative data can be continuous or discrete, and their values can be compared on a ratio scale. Why it is false? Qualitative data. Come on, qualitative data cannot be continuous. So qualitative means you are from, for example, it can be your hometown. You can from Brisbane, you can from Sydney, you can from Melbourne, is that right? So qualitative data can never be continuous, okay? It's just discrete. And it can be compared on a ratio scale. Yes, it is. We can see the proportion of the person from Brisbane or the proportion from Sydney or proportion from Melbourne, but it cannot be continuous, right? Qualitative, always, well, we can't say it is continuous or discrete because they are not numerical. Is that right? So this is, it's just wrong. We can't say it's continuous or discrete because they are not numerical value, right? So qualitative. So Ginger Lloyd, sorry Tony, what is the estimator again? Okay, estimator we call it's something we use to estimate parameter. Okay, so for example, if we are interested in the value of mu, but we can never know the true value of mu, so we use a tool x bar to estimate parameter mu, right? And this x bar is called the estimator of mu. Okay, or if we want to use we want to estimate population proportion, but we will never know the true value of population proportion, so we use p hat, the sample proportion, to estimate p. And so we can say p hat is an estimator of the population proportion p. Okay, Xiaofei Luo is asking, can you explain an example about confidence level question? But you won't be tested in your mid-semester exam because it's in week 1 to 5. So confidence interval, no. Confidence level interval, no. But if you do want, you can come to my consultation after this. Okay. Okay. Any other questions? If no question, we're gonna stop for today, okay? Any other questions, guys? Any other questions? Any other questions? Oh my God, hi Tony. Chen Yifan is asking, hi Tony, can you explain the end of chapter 5, exercise 9.15? Can you post that question for me? Because I don't have end of chapter 5 exercise. Can you tell me where can I find this question? I'll answer Dan Wu's question first, okay? Dan Wu is asking how to decide when to use CLT. So if you are asked, for example, what is the probability of the sample mean is less than 20, then you will probably consider using CLT because without CLT, you will never know the distribution of X bar, right? So you need to know the distribution of X bar first, which is a normal with mean and standard deviation, a sigma square divided by n of, the variance, and then you can calculate the probability of X bar less than 20, something like that, right? So this is when you determine when to use central limit theorem. But look, you need to make sure that either n is greater than 30 or the population is normal, right? In order to use the sampling distribution of sample mean to be a normal, okay? Right. And let's see Zhao Andy's question. Do I need to show the steps of the calculations in my test paper? Yes, you can. Why? If you have time, at least show the formula and show input all the numbers in the formula and then result. Okay? So first of all, show all the formula, the original formula, and then input the number in the formula and then result. I think that works fine. Okay? Crystal Han is, Chen Yifan is with a mean of, oh my god, a shipment of 500 cereal boxes delivered to a supermarket. The manager is told that the weights of the cereal boxes are normally distributed. So if you are watching the recording of this video, please look at the chat from Chen Yifan, okay? We can see the chat from Chen Yifan if you're watching the recording of this video. So a shipment of 500 cereal boxes, okay. And the manager told that the weights of the cereal boxes are normally distributed, all right, with a mean 165, standard deviation 5. Find the probability the random sample of 200 boxes have a mean weight between 164.9 and 165.1 G. So first of all, you need to make sure the question is asking the mean weight. It's not the weight of any particular cereal, right? So you need to know the mean weight. Okay, so for this question, we first let X bar be the mean weight of what? Of the cereals of 200 boxes, right? The weight of the cereal of the 600 boxes, all right? So you understand what is that, right? Now, since we know that n equal to 200 and it's greater than 30, therefore we know that X bar follows normal distribution with a mean equal to population mean. Population mean is 165. And the variance is sigma square divided by n. So it's 5 square divided by n. N is 200. So this is the sampling distribution of X bar. And you can also write approximately, right? Approximately. So it's good if you write approximately. So now we're going to find the probability of X bar what? Lies between 165.1 and 164.9. So you know it's using Excel, you can write down it's the probability of X bar less than 165.1 minus the probability of X bar minus 164.9, and it's equal to, so for example, if you can use Excel, right? So it's norm distribution, blah, 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 blah. You input the mean and the standard deviation. So the standard deviation is 5 divided by, or standard error is 5 divided by square root of 200. Is that right? So this is standard error, you input it and you can calculate the result. So I don't want to show you how to calculate this. This is pretty simple, right? When it is the normal distribution with mean 165 and the variance 5 squared. So the hardest part is to use central limit theorem. Is that right? So you need to know the question asking the average, the mean weight. It's not the weight of one particular one, right? It's asking the mean weight. So you know the population weight, and and this is how you use the mean weight. Ah, I see. 500 cereal boxes. Right. I know. For example, I know for the I guess there is some adjustment like big N minus N minus like N minus 1, something like that. I guess you are confusing about the answers provided, I guess. So you don't need to think about this adjustment for finite population size, okay? Because we see the population size is finite, which is 500. So we need to sometimes make adjustment on the standard error. But now you don't need to know it, okay? You don't need to know it. So if the question will not give you a finite population. So you can just assume it is infinite, and then you can do the question in this way, okay? So I guess that is why you are confused about it, Chen Yifan, because we haven't learned this, okay? Finite correction factor, we haven't learned this. So that's why you cannot understand the solution, I guess. So Crystal Han is asking, when the question said how many times an event happened in interval, it probably is Poisson distribution. What question said an event happened and probably is percentage is binomial. What is that? How many times the event happened in interval? It's probably is Poisson distribution. When question said an event happened and its probability is percent, it is binomial. So first, I need to clarify. We can never say a probability is some distribution, okay? That is absolutely wrong. We can never say probability is distribution, okay? We need to say a random variable, right? The random variable follows some distribution. Is that right? So therefore, if a random variable is the number of success for n times of repeating a Bernoulli trial, okay? Repeating a Bernoulli trial, then x follows binomial distribution NP. And if x is the number of occurrence within a time interval, then x follows Poisson distribution with the mean mu, and mean is the average occurrence within that interval, okay? So those are the differences between binomials. So you need to understand probability distribution is a feature of random variable. So we can never say this question is binomial distribution, or we can say the probability is binomial distribution, okay? The random variable follows some distribution, all right? Okay, so Leslie Shen, do we need to write approximately when using CLT? Yes, it's better, right? And Ranmo Liao asking for cluster sampling, the population is divided into heterogeneous groups. What does it mean? So for cluster sampling, the population is just divided into different groups. And these groups are heterogeneous, which means they are different, okay? For example, cluster sampling, we can divide the persons into different age groups, like 0 to 18, and 19 to 20, 19 to 30, 31 to 40, and 40 plus. Is that okay? So based on different proportion in the population, we proratally take a different number of samples in each group, okay? So this means hetero. Hetero means different. Genus means same. Heterogeneous means not same, okay? So we just divide them into different groups and take samples proportionally in each groups as a sample, okay? This is cluster sampling, I guess. And why the population is divided into groups of similar characteristics. So that is why it's wrong, right? If they are not into similar characteristics, right? Because they are heterogeneous, right? So that's why same characteristics is wrong. But when do we have the population divided into groups of similar characteristics? This is when we have a stratified sample, right? So for stratified sample, we just have a large group, and we divide this large group into different number of groups. But these groups are homogeneous, which means they are basically the same. So we only pick, for example, one group from here, one whole group from here. This is stratified sampling, okay? So don't mix up the cluster sampling and stratified sampling. Right. Any other questions, guys? When do we need to round up? Okay. When do we need to round up? It's, come on. When something is like over 0.5, you round up, right? If it is less than 5, like 4, you round down, right? So this is when you round up and round down. Any other questions? Okay. If you don't have any other questions, it's the right time for us to call it a day. Okay. So my last words for your mid-semester exam is that don't be panic. Okay, everything will be fine. And take your but you need to pay attention on the time, because I'm afraid that you know how to do every single question, but you don't have enough time to finish them all. Okay, so you need to keep in mind. Yeah, I need to have some water. Yeah, definitely. And sure. What else? Well, no worries. I'll just see some of you on Sunday night. Okay, I know your exam is on Sunday night, starting from 6, and I will be in one of your computer labs, helping with your software of any issues that you probably encountering in your exams. Okay, I will be in H69 Lab 1. So who is in there? I will see you on Sunday night. Okay, wish you the best luck in your exams. And that's all for today's live streaming consultation. Thanks for your support for my live streaming, and thanks for your support for PLG. And later on, you can rewatch this video in our video channel. Okay? Right. That's all about today. Thank you very much. And lastly, I would like to say, okay, I want to change the camera. Oh, how? Okay, guys. Thanks for watching. I'll see you on Sunday night. Bye-bye.